So in this video, I'm just going through how to solve simultaneous equations. So a simultaneous equation is just different to normal equation in that it's got two variables. You can see you've got x and y. You know the regular equation, say if you had something like this, 2x plus 3 is equal to 9. And you wanted to solve that, you'd bring across your 3 and you'd find out the value for x would be 2x is equal to 9 plus 3 is equal to 12, or 9 minus 3, which will give you a 6. And then you see in this case, x is equal to 3. So that's going to make sense, because if we take x is equal to 3 and we put it in here, you get 2 times 3 is 6. So 6 plus 3 is equal to 9. So there's only one solution for this. But in here, we're going to try and find something that satisfies two different equations. So it'd be like if somebody told you 3 times one number plus another number is equal to 7. And if they said the first number plus the second number is also equal to 5, solve for that. What are our values for x and y? That's what we're trying to solve here. So I'll jump right into the first question. You can see in this one, the first thing we need to do is we need to do something that's going to cancel the two of these out. So I'll start explaining it now, and maybe it'll make sense after I go through this one. So this bottom line, what you're going to do is you're going to multiply this by 3. And it'll be apparent why I picked 3 now in just 2 seconds. So we're going to come down and we're going to go to our next line. So we don't change the first one, we leave that as it is. We write 3x plus y is equal to 7. The next line then, what we're going to do is multiply each one. So we're going to take the first part here, you can see it's x, we're going to multiply that by 3. So we're going to get 3x, take the next line, which you can see is y, we're going to multiply that by 3 also, that's going to give us 3y, and then we need to take the last term, which is 5, and we multiply that by 3 and we get 15. Now the next thing we do is we just put a line underneath these two equations. And we know we're ready to actually put a line underneath the two of these equations, because now we have got we've got a 3 and a 3 here. So you're just going to add these up like you would normally add numbers, with a difference. You can see that 3, if we were going to add 3 and 3, we'll end up getting 6x. But what we actually want to happen here is that the x's will cancel out with each other. So what we do is we get, and you can get a different color pen for this, and we can change the sign of the bottom one. So you can see this is changed to a minus, this is changed to a minus, and we've got this changed to minus as well. If some of you would like to think about it as well, you could have multiplied by minus 3 at this point here instead of 3, and it would have done this all for you. But I think this might be slightly easier to understand. So the next thing you do is you take 3 minus 3x, the two of these are going to cancel out and you get 0. I won't write anything there because there's nothing below it. Then you're going to have y minus 3y, that gives you minus 2y, is equal to 7 minus 15, which gives you minus 8. The next thing you can do is you can divide either side of this equation by minus 2. So minus 2 into this gives you y, and minus 2 into this. And you don't have to write this in, but I'll just put it in for the sake of it here. Dividing this by minus 2, dividing this by minus 2. Just remember that the rules for division and multiplication are the same. So you can see in this case, when you've got a minus divided into a minus, in the same way that if you have a minus multiplied by a minus, you're going to get a plus. So 2 minus 2 gives us into 8 gives us a positive number, and it's going to give us 4. So for this one, we're going to go y is equal to, so by the way, these two 2's cancel out here, and minus 2 into this is going to give you 4. So plus 4, y is equal to plus 4. So that's our first number. Our second one, now you can take either of these equations at the top. So you can take either this equation or the bottom one. It doesn't matter. It looks a little bit easier. I'm going to take the bottom one here. So just put an arrow coming up from that. And what we're going to do is substitute y is equal to 4 into that. X plus y is equal to 5. So then we just take this equation, and we just, anywhere that we see a y, we're just going to replace it with a 4. So take x, and then our y is just going to become 4. We're going to put that in there, is equal to 5. And then we can finish off and just put an arrow in so you can see that this y has just been replaced with a 4. And then we're going to take our 4 move it over onto our right hand side, we'll get x is equal to 5 minus 4, and then finally you've got x is equal to 1. Now this is not a necessary part of this, but just for the sake of showing you what's happening here, we're going to actually put these numbers, x is equal to 1 and y is equal to 4, up into the two of these equations and see do they work. So if you want to think about it, y is equal to 4, and we'll just write this in red above it. If this was equal to 4, we would get in total 3 times 4, or sorry, x is equal to 1. So for this one, we're just going to get 3 plus y is equal to 4. So 3 plus 4 is equal to 7. You can see that's correct. And then if we look at this one of x and y, 4 plus 1, 1 for x, 4 for y, and you can see they're both equal to 5. And that's what we're trying to find, sets of numbers that will satisfy both of these equations. So now we're going to try a different example here. So for this one, similar enough process, I think, to solving the first one. Actually, I overlooked something from our first question. For this, it would have actually been easier. I won't bother going back over it, but for this, it would have probably been easier if we had just cancelled out our y's. So we didn't actually need to, I jumped ahead of myself there, we didn't actually need to multiply by anything. We could have just cancelled these two y's out straight away for this question. But not incorrect what I did, but it's probably the longer way of doing it. So if you take this one then, so this time we're going to multiply the top one. So if we look here, we want to make either these the same or these ones the same. So you can actually cancel x or y at this point. It doesn't matter which one you want to do. But you can see that for x, all we have to do is multiply this by 3. And then the two of these x's will cancel out. So go over here, we're going to multiply it by 3. And then we'll come down to our next line. So we're just only going to change the top one. So it's going to get 3x, because we've got 3 multiplied by x, plus 6y, because you're multiplying this 2y multiplied by 3. And then finally we're going to multiply 12 by 3, and we're going to get 36. Then we're just going to put the other line down here, 3x minus 5y is equal to 3. Then we put our line below here. Now these have the same sign, so if you were to add up the two of these, you'd end up getting 6, but we want them to cancel out with each other. So for that reason, we're going to have to change the signs on the bottom one here. So we just change this to minus 3 plus 5, and then we're going to have minus 3. We do out our sum, we're going to get the two of these will cancel out. 6 plus 5 gives us 11y, and then 36 minus 3 gives us 33. Divide both sides by 11, we get y is equal to 3. Then we pick one of the equations. We can pick the top or the bottom one, it doesn't matter. I'll pick the top one this time. Bring it out here. X plus 2y is equal to 12. And then again, we just, like our last time, we just substitute y in for our y here. So we're just going to replace that with 3. So what you'll get is x plus 2 times 3, just undo there, 2 times 3 is equal to 12. So you can see that's x plus 6 is equal to 12. Bring the 6 over, and I'll do this step by step. So we'll go 12, bring our 6 over to this side here, and when you bring it over, you just need to change its sign from a plus to a minus. So you get x is equal to 6. And again, you could go and just check, these line up with our top equation, so you would see that they should. X is equal to 6, so this would be 6 plus 2 times 3, which is equal to 12, that's correct. And then we've got 3 times 6, because x is replaced with 6, so 3 times 6 is going to give you 18, minus 5 times 3, so 18 minus 15, you can see that's going to give you 3, which is correct there. Now this time it's going to be a similar problem, but we just need to do a little bit of rearranging first. If we looked at this last example, you can see that the x's are on top of each other. So you've got this x on top of this 3x, and you've got the y above on top of the y, and we've got the number, so the constant above the constant. It doesn't actually, you can put them in this position where you have the x's first, the y's second, and then an equal sign, and that's equal to 12. You can do it that way, but it actually doesn't matter what order they're in, as long as the x's are on top of each other, as long as they're in the same order. So if we come on to the next one, we're going to rearrange these two equations. So what I'm going to do is just swap them around so that the x's are above the x's. So the step one will be to move this 2 over, so it's below this. And we also need to move the y over here, so it's on top of this one. I'll go through that now. So take the first line. So we keep 3x there. We're going to then move our y over. And you remember when you move something over, you just need to change the sign. So we get minus y, and then we can leave 4 where it is. So we get a negative 4 there. And then we're going to take keep our 3y where it is. We're going to move our 2x over, remembering to change our sign, it becomes a plus 2x. So you get 2x plus 3y is equal to 34. Now, at this case, we can start changing things. So we want the y's to be the exact same. So we can multiply this line by a number, this line by a number, or sometimes we'll have to multiply both lines for a number. Now, for solving this, the easiest way would be to multiply y by 3. But you might not always get a question this easy. So what I'm going to do is I'm actually going to cancel the x's out this time. Not the easiest way for this particular question, but it's still good to know because you won't always have an option where you only have to just multiply one of them. So if there's a 3 here and there's a 2 here, this time what I'm going to do is I'm going to multiply this one by 2, and then I'm going to multiply this line by 3. And what's happening here is, you'll see this when I multiply them out, this will become 6, and this will also become 6. So these will be the same, and then we'll be able to cancel them out. So coming down to my next line, we're going to multiply the top one, we'll get 6x. You're going to get 6x minus 2y is equal to minus 8. So all I did with this one was I just multiplied this whole line by 2. Then we're going to take our next line and we're going to get 6x again plus 9y is equal to 34. It's going to be 98, 102. Next, we're just going to do our line below these because we'll be able to start cancelling things. Now, sometimes in this question, if you'd, just to note, if you'd multiplied y by 3, in this case you wouldn't have actually changed signs because they would cancel out automatically because this would be a plus and this would be a negative. But for this one, we will have to change the signs because if you just went ahead and added these 6 and 6, this will end up giving you 12, but we want to get a 0. We want these to cancel each other out. So for this one, you go change the sign of this becomes a negative, this becomes a negative, and this becomes a negative. So they're going to be all negatives here. So next thing you do, you're going to cancel your 2 6's out. You're going to get minus 9 minus 2, and this will give you minus 11y. And this then is going to be equal. This then will give us minus 8 minus 102 is going to give us minus 110. So in this case, we can divide both sides by minus 11. I'll skip through this one. So it's going to be y minus 11 into this gives us y, and then minus 11 into this, and minus into minus is going to give us plus 10 times. So y is going to be equal to 10. Then we just do the same process as before. We just take either of these equations. It doesn't matter if we take the original one or the modified one. I'll take one of the original ones. And 3x is equal to y minus 4. And this time we're just going to replace y with 10. So you're going to get 3x is equal to 10 minus 4. 3x is equal to 6. And then x is equal to 2. You divide both sides by 3. So just remember, if you put this into any of these equations, the left hand side should balance the right hand side. So if we think about x is equal to 2, let's take 3 times 2 is going to give us 6 on this side. And then we've got y minus 4. Y is going to be equal to 10. and you can see 10 minus 4 is going to give us 6 on this side as well. Same thing with this side, you're going to get 3y's will give us 30, and then we're going to get 34 minus 2 times 2, which will give us 4, and these will be equal on both sides, and that's what we've just found. Now finally, we're just going to look at a question with fractions in it. So when you see fractions, you just want to get rid of the fractions first of all, just to make it more manageable. So if you want to get rid of these two factors, these two fractions right here, so you see we've got 2 and then we've got 5. What we want to do is pick a number, and I'll do this out of the side, so you can work straight down, but just I'll do this outside in rough work to show you exactly what's happening. If we multiply this by 10, so we try and find the lowest common multiple, so the lowest number that the two of them will actually divide into. So for this one, 10 is the smallest number the two of these will divide into, and then 4 is the smallest number the two of these will divide into. So that's what I'm going to multiply across, and I'll show you at the side here how that's going to work. If we take the top equation, x over 2 plus y over 5 is equal to 4. Now if we multiply this by 10, just extend out this line, this by 10, so when you're multiplying by 10, you multiply every term by 10, and then this by 10, this is what's going to happen. We come down to our next line, the 2 right here is going to divide into the 10, so 2 goes into 10, it gives us 5. So we're going to end up with 5x there, plus the 5 goes into the 10, that's going to give us 2y, and this is going to be equal to 40. So we have the first one there done there for you already. So it's going to be 5x, we come down to our next line, 5x plus 2y, and this is equal to 40. Then we come to our next line, so this one here we're going to be multiplying by 10, and this one here we're going to be multiplying by 4. So I'll actually do this again, I'll do the other one out my rough work here at the side. So x over 4 plus y over 2 is equal to 6. So again, we're going to multiply across, and I'll do it in red this time. Multiply across by 4 here, and then multiply by 4 here. And this is going to give us, you can see the 4 is going to divide into 4, we'll be left with x, and then the 2 divides into the 4, we're left with a 2y. And then you just multiply the 6 by 4 as well. So for this one, you're just going to go x plus 2 into 4 is going to give you 2y is equal to 24 if we multiply 6 by 4. So we've got x plus 2y is equal to 24. And then just again, this time the sum has actually been nicely tidied up. We don't have to multiply by anything to change them, because you can see here we've got these two 2's will cancel each other out. But in other questions it mightn't work out like that. For example, if we wanted to cancel the x's here, we'd have to multiply this one by 5. But we don't have to do anything. But we do need to change our signs. If this was a negative, we just leave everything as it is. But since it's a positive, we need to change this to a negative. So we can go like this. This is a minus, this is a minus, and this is a minus. So what we're going to get is 5x minus x is just going to give us 4x. The two of these cancel out, and then we get 40 minus 24, that's going to give us 16. If we divide both sides of this by 4, then we're going to get x is equal to 4. So we found our value for x. And I just delete this out for a second. So we'll take over. Now we could take either the top or the bottom equation and it will completely work. But you can see it'll probably be a little bit easier if we take this one right here. So I'll actually do it two ways. I'll solve it. The easiest way will be to just pick 5x plus 2y is equal to 40. I'll do that first, and then I'll show you what would happen if you just took another one, just to show you that it will work out the same. So here we've got 5x plus 2y is equal to 40. Then we're going to just substitute. We know that x is equal to 4, so we're just going to change x with a 4. So we're going to get 5 times 4 plus 2 times y is equal to 40. You've got 2y, multiply the 5 and the 4 out. Okay, we'll just do that line by line. So you could do some of this in your head. You might need to do as many steps as I'm doing here. 2y is equal to 40 minus 20, because we're bringing this 20 over here, and just remember that we should be changing the sign of that. So you get 2y is equal to 20, divide both sides, and we'll get y is equal to 10. Now, I'm just going to show you for the sake of it, that's our problem completely finished. You can see if I put that into any of these, x is equal to 4, we'd have, I'll just write it in here quickly so we can see it. If we put in 4 there instead of x, and if instead of y, if we ended up putting in 10, well, you'd have 4 divided by 2, I'll write this in a different colour. 2 into 4 would give us 2, 5 into 10 would give us 2, and you can see 2 plus 2 is equal to 4 on this one. So just what would have happened if we'd picked this equation instead? So if we pick this top one, I'll just go over this with a rubber quickly. So if we pick this equation instead, you'll find that it'll actually still work out. We'll still get the same value for y. So imagine we only had x at this stage.